the world's largest tunnel boring machine work? Perhaps the easiest way to answer this question is to demonstrate how the Heron Connect S574 earth pressure balance shield is being used in the Galleria Sparvo project. As part of the 3-lane widening of the A1 Autostrada in Italy, the machine is boring a 2.5-kilometer tunnel section between Bologna and Florence. The route model shows the S-shaped line of the section being tunneled. After completion of the first bore, the machine is turned and then drives the second bore parallel to the first. The local geology comprises mainly clay, argillite, sandstone, and limestone. A particular challenge is posed by strata containing methane. The machine has been specially equipped to deal with this problem. The S574 is an EPB shield with an outer diameter of 15.55 meters and an overall length of 120 meters. With its rotating cutting wheel, the tunnel boring machine removes the material at the tunnel face. A screw conveyor then moves the excavated soil to conveyor belts behind the EPB shield. While all this is going on, hydraulic cylinders continuously drive the tunneling machine forward. Protected by the shield skin, the reinforced concrete segments are set in place. When a complete ring has been built, the machine is able to push off from the newly installed tunnel ring and continue boring into the ground. The 105-meter-long backup houses all the logistics equipment needed to operate the entire system. All the key information, with the current tunneling parameters, is fed into the central control cabin. Here it is visualized on screens for the TBM operator, who is able to monitor the largely automated processes. The way an EPB shield works can essentially be divided into two phases: the tunneling phase and the ring building phase. In the tunneling phase, hydraulic thrust cylinders apply a pressure of up to 500 bar to push the cutting wheel against the tunnel face. It rotates at speeds of up to 2 revolutions per minute. 50 hydraulic motors, developing as much as 94,100 kilonewton meters torque, power the cutting wheel via the gear rim. The high pressure and torque enable the high-strength steel disc cutters and cutting knives to easily remove the material at the tunnel face. During shield drives in unstable ground, face support pressure is generated to counteract any loss of stability at the tunnel face. On an earth pressure balance shield, the soil excavated by the cutting wheel is used to support the tunnel face. During advance, the excavation chamber is permanently completely filled, preventing settlement on the surface and the buildup of explosive mixtures. To achieve a state of balance, the face support pressure is transmitted from the hydraulic thrust cylinders to the loose soil through the bulkhead, thereby preventing uncontrolled penetration into the ground. The internal stators and rotors cut through the soil mixture, while foam can be injected via nozzles to ensure the required consistency is maintained. A screw conveyor now removes the treated soil from the invert area of the excavation chamber to a conveyor belt. The screw conveyor is powered by 4 hydraulic motors, delivering 1,200 kilowatts. The speed of rotation regulates the volume of soil removed from the excavation chamber and adjusts it to the advanced speed. The aim is to keep a balance between the volume of soil removed by the screw conveyor and the volume of soil being produced by the advance of the EPB shield. This makes it possible to ensure optimal support of the tunnel face. One of the risks inherent in tunneling along the route is the occurrence of explosive fire damp. Measures have to be taken to eliminate the risk of explosion. As a safety precaution, the conveyor belt is housed, from the screw conveyor discharge to delivery to the cross-belt conveyor on gantry number 3. A continuous feed of large volumes of fresh air greatly reduces the gas content inside the bore. Further mixing is carried out at the open outlet. The machine is fitted out with explosion protection equipment, and the concentrations and gas tightness of the system are continuously monitored. This allows a controlled excavation process, even in sections where there is a possibility of the occurrence of fire damp. Once the tunnel phase has been completed, cutting wheel and screw conveyor are stopped. The ring building phase now commences under atmospheric pressure conditions in the shield area. A complete tunnel ring consists of several segments, called lining segments. These prefabricated reinforced concrete elements are precision produced on the surface in a specially set up production plant and, following quality inspection, are taken into the tunnel on carriages. At the front end of the carriage, the segments are individually raised by a special transfer crane and placed on the segment feeder, which brings the segments to the front area of the tunnel. Here, the segments, weighing several metric tons, are lifted by vacuum plates on the erector, a hydraulically controlled crane arm, and moved into place. The erector runs on 2 rails and can be moved, rotated, and telescoped. Each complete tunnel ring is made up of a number of standard segments, together with 2 counter key segments and 1 key segment. The segments are always installed in the same sequence. The erector raises the segment off the segment feeder. The hydraulic thrust cylinders are then retracted to the relevant installation position. Using remote control, the segment is then positioned by eye exactly against the last installed ring. The hydraulic cylinders are now extended again to secure the segment in its position. The segment is then bolted to the previous ring. The segments continue to be placed on alternate sides. Finally, the key segment, with slanted longitudinal joints, provides inherent locking in the ring, completing the ring building phase, ready for the next tunneling phase to begin. A fast motion sequence illustrates the 2 working phases of the TBM. The tunneling phase and ring building phase continuously alternate, so that the tunnel grows ring by ring. Under optimal conditions, it is possible to achieve more than 100 meters advance weekly. This involves shifting up to 20,000 cubic meters of excavated material and installing well in excess of 500 segments. Heron Connect earth pressure balance shields are normally in their element in cohesive soils of clay and silt, with low levels of water permeability. However, EPB technology also allows successful tunneling in loose sand and gravel soils and solid rock. The technology has been proven worldwide on an extremely diverse range of traffic tunneling projects. The range of applications of this type of machine is now being even further extended with the use of the 15.55-meter diameter Heron Connect EPB shield on the Galleria Sparvo project.